Hi guys, thank you for joining me. Today we have another interesting topic, algorithm and flowchart. So join me as we look at our learning objectives together. So we have our 5 learning objectives for today. The first, state things to consider while writing algorithm. 2, list flowchart symbols. 3, draw and identify flowchart symbols. And 4, write a simple algorithm for solving problems. And 5, draw a flowchart to represent algorithm. Now, before we go further, I would like us to quickly look at our last lesson where we define algorithm. And friends, what is algorithm? We can say algorithm is a step-by-step process of solving problems. I believe you still remember that. Now, let's look at the functions of algorithm that we discussed last week, where we have 1. It guides the programmer to follow the instruction in an orderly manner. It is written in human language and it prevents omission of steps. And the last one is it prevents duplication of steps. And we look at 2 types of algorithm. We have the pseudocode and the flowchart. And we say pseudocode is the narrative description of algorithm. And it is written in English-like statements, just like when you are writing a short story. And we discuss flowchart too, that uses symbols and shapes. Then we mention application areas of algorithm, where we said it can be used in computing, in mathematics, and in solving human problems. Now, back to our lesson for today. Things to consider while writing algorithm. That is, what are the things to consider, to take note of while writing algorithm? The first one I would like us to discuss today is algorithm must have a beginning and an end. There must be a beginning and an end in algorithm. Like for example, when you turn on a computer and turn it off, the program you are running will definitely stop. That's the same way we write algorithm. We start with begin or start, and we stop it with an end. There's no program that can continue forever. There must be a time you terminate the program. Alright? Now, let's look at number 2. Algorithm must have a number of steps. Like in our example today, we have some that has 5 steps and we have another one that has 8 steps. It depends on the kind of program you are working with or the algorithm that will determine the steps that you want to take. Alright, let's look at 3. The instruction must be clear to be understood. That is not only by you alone, but by other programmers. Because if it is not clear, it means you are going nowhere. Alright, now number 4. The steps in solving a problem must be in the right order to achieve a desired result. What do we mean by that? It means to solve the problem, you must arrange the steps in an orderly manner. If you take, maybe for example, the step that should be in maybe step 3 and you put it in step 5, the program will not give you a desired result. So that is why it must be in the right order. You must arrange it in the right order. Now, let's look at flowchart symbols. We have 5 flowchart symbols. I repeat, 5 flowchart symbols. The first one, terminal symbol. 2, input-output symbol. 3, processing symbol. 4, decision symbol. And 5, direction flow symbol. Now, let's look at what they look like. The terminal symbol is oval shape. All these shapes, they are the same shapes we used in mathematics. So terminal symbol is oval shape, while input and output symbol is parallelogram, while the processing symbol is rectangle, and decision symbol is diamond shape. And we also have arrow or line that join one flowchart to the other, and we call it direction flow line. Now let's look at the uses of each of these symbol. Terminal symbol, that's number one. This oval shape is used to begin and end a flowchart. That is, when you draw a flowchart, you will see it at the beginning, and when you end the flowchart, you will still put the terminal symbol. Then we also have the input and output symbol, the parallelogram shape, which shows the operation. And there are some statements or keywords that we put there, like input, like print, like read, and data. When we look at our example, you will understand it better. Now, the third one is processing symbol. This is a rectangular shape and it indicates a processing operations, e.g., like for example, the process you want to use in carrying out the work. Like for example, what you are saying on the board, C equal A plus B. That's the process you want to take. Alright, let's look at number 4, decision symbol. This diamond shape shows a decision operation. That is, where you are not clear of decision you want to take. Like, should I go to school tomorrow or not? So, that question is yes or no question. And that is why we use decision symbol. We have an algorithm and a flowchart that has this. So in our example, you will say that. Alright, the last one is direction flow. These arrows shows the direction of instruction from one symbol to another. That is, it joins one symbol to the other. Now, let's look at a simple algorithm to compute child's morning routine. That is, if you want to write this algorithm, what are the steps you are going to take? So let's look at the board. Alright, you need to take step 1, which is start. Remember, I said algorithm must have a beginning and an end. So you step 1, start. Step 2, leave home. Step 3, check time. Step 4, if the time is before 7 a.m., take a subway. And or else, take a bus. That's step 5. Or step 6, reach school. And step 7, end the program. Alright, I believe you follow the step. Now, what do you think the flowchart will look like? Now let's look at it together. Now this is the flowchart for that particular algorithm. That is, leave home, check time, before 7 a.m., yes or no, take a bus or take a subway and reach school. If we look at this diagram here, you will see that the terminal symbol is used in the first and the last, and followed by, if you look at the second shape, is the input and output, the parallelogram. And look at decision, where you have before 7 a.m. and look at the process symbol, where you have take bus, take subway, and last one, reach school. Now I would like us to look at another one. Now this is another algorithm to add 3 numbers. Now let's look at it together. Step 1, start. Step 2, enter the first number. Step 3, enter the second number. Step 4, enter the third number. Step 5, add the numbers together. And step 6, show the answer. And step 7, end. That is, for you to add 3 numbers together and get the answer just like the way you do it in mathematics, that is the step you will follow. Alright, let's look at the flowchart. The flowchart to add 3 numbers. As you can see, we still have start and we have end, because that is what always starts the flowchart, even the algorithm, and it must have end. So if we look at after the start, we have about 4 processing symbols. For example, let A equal 5, let B equal 10, let C equal 15, and sum equal A plus B plus C. Then the second to the last is print sum, which is parallelogram, and end. I believe if you look at this picture very well, you'll be able to know what to put in each of the symbol from your algorithm. Like this is pseudocode, you still remember, why this one is now our flow chart. Now let's look at the last one. Write a simple algorithm to find the sum and average of any 3 numbers. Remember, if you want to find average, you will add all the numbers together and divide it by the number itself. So now let's look at the step. Step 1, start. Step 2, input the first number. Step 3, input the second number. Step 4, input the third number. Step 5, add the numbers together. And step 6, divide answer by 3 to get the average. Then step 7, display sum. Step 8, display average. And step 9, end. Now let's look at the flowchart for this algorithm. Now look at the flowchart to add the 3 numbers. Now the first shape that we have here is start, and followed by processing symbol, and followed by another processing symbol, because that's the process we want to take. Then we now have print sum or print average. So that is in parallelogram, and we must end the program. So that is why we have end. I believe this is clear enough. If we look at the algorithm, is written in English-like statement. Is a narrative description of algorithm. That is pseudocode. This one you are seeing on the board. And the flowchart is the one that use the shapes or symbols to represent the algorithm. And remember, I said something last week that you must write the pseudocode first before you can now transfer it to draw your flowchart, because flowchart is closer to the program. It's to show you how the program will look like and whether it will work or not. So now I believe you understand everything. Now let's quickly look at our learning objectives for today, the summary of our work. Alright, we see these are the list of our objectives. So we are going to take the summary now. So at the beginning of our lesson today, we state things to consider while writing algorithm. So I would like to preview that for you again. Alright, we said algorithm must have a beginning and an end. 2, algorithm must have a number of steps. Then 3, the instructions must be clear to be understood. Then 4, the steps in solving a problem must be in the right order to achieve a desired result. Then we look at the flowchart symbols or shapes, where we have terminal symbol, input and output symbol, processing symbol, decision symbol, and direction flow symbol. And we'll look at what each of the symbol look like. As you can see, we have oval shape, parallelogram, then we have processing symbol, we have decision symbol, and we have the arrow that join them together. And we'll look at the uses too. In oval shape, we have begin and end. That one is permanent. That is what you always see in the oval shape. And we have the input and output. Input to enter our data, and to bring out the data out is output. So it shows the operation of our work. Then we have processing symbol, the rectangular shape, which is used to show the process of our work. And we also have decision symbol, which we can use to make a yes or no question in computer when you are not sure of the answer. Alright, then the last one, direction flow, the arrow that join the flowchart symbol to another one. Then we'll look at some examples. This one is written in pseudocode. This one is written in flowcharts. We draw it with shapes. Then we look at another example. To add 3 numbers, we follow the step. You will realize that it's the same as when you want to solve a simple mathematics. So thank you.